In this chapter, you're going to learn how to check if there is a linear relationship between two variables. One is called the independent variable, which is the predictor variable, and the other one is called the dependent variable, which is called the response variable as well. You have seen this before, the linear relationship using the equation of the line y equals mx plus b. So you probably familiar, with the linear relationship between variables through the equation y equals mx plus b, where m is the slope and b is the y-intercept. So in this chapter, you're going to be giving two variables. Like, for example, I'm going to start with this example, which I did explain in the summary of chapter 4. Let's say we have information about the number of hours the students study for the test and the exam score and the test score that they get based on the number of hours they study. We wanted to check if there is a linear relationship between the hours of study and the scores, meaning we wanted to check if the students increase their number of hours of study, would that increase their test score or not? To do this, we're going to do two things. First of all, we're going to do a scatter plot where we're going to plot this data. Like for 1 hour, if you study for 1 hour, you score 55. If you study for 2 hours, you're going to score 57. You study for 3 hours, you're going to score 60, and so on and so forth. So what we're going to see if there is a linear relationship by a visual. First of all, you just look at the points, the dots that you're going to plot, and you probably can tell. So let me show you how to do the visual. You can go to graph, you can go scatter plot, select the x variable, which is the hours, select the y variable. Oops, the x variable is hidden. I haven't selected the x variable yet. So let me just select that. Select the x variable, which is the hours, the y variables, which is the score, and hit compute. And look. As you notice, you look at the dots. This is an upward trend, so it means as x increases, y increases, and it looks like it's pretty much a steady increase, like they seem to belong, to a line, which is gonna call it the regression line or line of best fit. See how the mouse, just is moving over it. It seems like it's moving in the direction of an oblique line that shows as x increases, y increases. So from the visual itself, you can say that they're probably a linear relationship. But now I'm going to show you how to find a number. It's called sample correlation coefficient. And once you find this number, you should be able to tell, just that whether based on the sample, whether you can make a conclusion that there is a linear relationship between the two variables. So here's how we find this number. It's called Pearson correlation coefficient. I'm going to show you how to find it using StatCrunch. You go to Stat, Regression, Simple Linear. You select your x variable. You select your y variable. And you just hit compute. And watch. Not only it gives me this, but it gives you the scatter plot again. Look, this is the scatter plot. And this is the line that I was telling you about. It looks like all the points belong to the line. They're not all on the line, but it seems, that this is a line that represents all those dots. So what is the Pearson correlation coefficient? It's right here. And if you read the value, it's 0.977. Let me explain this value. If r turns out to be very close to 1 or very close to -1, then there is a linear relationship. If it is positive, then the linear relationship is positive, meaning as x increases, y increases. But if this, let's say, for example, was -0.97, then you can say that there appears to be a negative linear relationship between x and y, meaning as x increases, y decreases. So this is how you interpret r. If R is close to 0, you will say that the linear relationship is very weak. It has to be close to 1 or close to -1 to make kind of inference that there is a linear relationship. Now I showed you the equation of the line, guys. The line itself, look, it's right here. What is the equation of this line? It's y equals mx plus b, and look, you already have it. It's right there. Because I called the score a y, so it's displaying y equals 50.33 plus 3x. The 3 is called the slope of the line, and the 50.33 is the y-intercept. The slope of the line, if you want to interpret here, it means for each additional hour of study, your score will increase by 3 points. So this is what the equation of the line means as far as the slope and the y-intercept. Now, if you have the equation of the line, I could ask you, can you predict the test score if a student study 8.5 hours? So all you have to do, guys, is just plug in x equals 8.5 multiplied by 3 and add 50.33. That will give you the predicted score. It's a prediction. So you can use the equation of the line to make predictions. Okay? Now let's explain what r squared means here. If I ask you, for example, on the test to find r squared and explain its meaning. So r squared means r times r. So if you multiply those two numbers, the number by itself, you're going to give you 0.95. So let's change r squared to a percentage. So it's going to be 95.5%. Here is how you interpret r squared, and this is called the coefficient of determination. You will say 95.5% of the variation in the test scores can be explained by the variation in the number of hours studied using the regression line. So this is the interpretation of r squared. There is one more thing, and that would be it for this chapter. If I ask you, can you conclude if the correlation means linear relationship, is significant between the two variables? And here's how, according to the sample, it appears that there is a relationship. But if you want to generalize for the entire population, like, is there a significant correlation between the number of hours a student study and the test scores in general, not only for those 12 students that we did right here? So here is how you do that. I'm going to show you how to do this. You already found R. So R is 0.977, I think. So here's how you check if the correlation is significant between the hours and the test score. You find the sample size, and our sample size was 12. You get the critical number from the sample, from this table. It's called the Pearson correlation table. The critical value, what is the critical value based on the 12, is 0.576. If this number, the 0.977 in absolute value, is greater than this number that you found using the table, then you can say that a linear relationship exists between the two variables. If this number turned out to be smaller than the number that you found using the table, then you say no linear relationship exists between the two variables. So probably the question you want to ask now, would I provide you with this table? If I ask you this question, of course, you will be provided with this table, because I don't expect you to memorize this table. The last thing I would like you just to know about is a residual. What is a residual? Look, you have to, these are the values here that we put in StatCrunch are the actual value, the observed values. But when we plug in x equals 4 in the equation of the line and we get a y, this is called the predicted value. The difference between the observed values and the predicted values are called residuals. Okay, so it is the leftover after your line makes a prediction. A residual is the actual value minus the predicted value. For example, if your model predicts 76 but the actual value is 80, then the residual is 80 minus 76, which is 4. If R, the correlation coefficient, is very high, then you expect your residuals to be very low, which is a good thing. Correlation vice causation. You have to understand one thing. If two variables are related, it does not mean that one causes the other. I'm going to give you an example. You know, there is a strong relationship between smoking tobacco and lung cancer. There is an association, there is a relationship between the two. The more the person smokes tobacco, the higher the risk of getting lung cancer. But it does not mean if someone smokes tobacco that he or she, for sure, they're going to get, just lung cancer. So this is a difference between causation and correlation. This is pretty much it in this chapter. Make sure to check my summary in Moodle and then proceed to the homework and interactive assignments on the Pearson website as soon as you watch this video and go through my summary.